Light feels simple. You flip a switch, a room brightens. You look at the sun, and 8 minutes later its glow reaches your eyes. A laser pointer draws a thin red line across a wall, sharp and obedient. The picture in your mind is clean. Light is something that leaves a source and travels straight through space like a microscopic bullet, moving from point A to point B along a definite path. It is fast, unimaginably fast, but still a traveler. That is the intuition almost everyone carries, and it seems reasonable. After all, we can trace rays and diagrams. We draw straight lines bouncing off mirrors, bending through glass, reflecting, refracting, behaving like disciplined messengers, obeying geometry. Even the language reinforces it. We say light moves, goes, arrives, the beam travels, the photon flies, the signal crosses space. Everything about our vocabulary suggests motion along a path. But that picture hides assumptions. It assumes that light has a single trajectory. It assumes there is a tiny thing somewhere between the source and your eye, occupying a specific location at each instant. It assumes that empty space is merely a stage through which this thing passes unchanged, except when deflected by matter. Most importantly, it assumes that travel means the same thing for light as it does for a thrown stone. That is where the trouble begins. If light truly behaved like a miniature projectile, then at every moment between emission and detection, we should be able to describe where it is. Even if we cannot measure it precisely, we should be able to imagine it as following one definite route, a path through space, a world line you could draw with confidence. That mental image is so deeply embedded that abandoning it feels almost absurd. Yet the deeper we look, the less that image survives. At microscopic scales, light refuses to commit to a single path. In gravitational fields, it does not move through space so much as follow the curvature of space itself. In quantum experiments, it behaves as if it explores multiple routes simultaneously. Even the concept of a rigid, straight beam dissolves under scrutiny. What appears to be a line is a structured field, extended and dynamic, not a narrow object slicing through emptiness. This does not mean light is mysterious in a mystical sense. It means our everyday picture is incomplete in a structural sense. The diagrams are useful, the ray models work for lenses and mirrors. But usefulness is not the same as truth. A map can guide you without revealing the terrain's full geometry. So before we move further, hold the simple image in your mind, a beam shooting cleanly through space, because in the next step we are going to examine it carefully. And once you see what that image leaves out, it will never look quite as solid again. To understand why the simple beam picture feels so convincing, we have to look at what we were actually taught in school. Light is introduced in two neat packages. First, it is a wave, an electromagnetic disturbance moving through space at a fixed speed, about 300 million meters per second. Later, it is also described as a particle, a photon, a tiny packet of energy traveling through the vacuum. Two models, both elegant, both powerful, both apparently complete. In the wave model, light is an oscillation of electric and magnetic fields. These fields rise and fall, perpendicular to each other, marching forward in space. The mathematics predicts exactly how fast they move and how they interact with matter. Mirrors reflect because charges in the surface respond to the incoming field. Glass bends light because the oscillation slows slightly inside the material. Everything fits beautifully within Maxwell's equations. The wave spreads outward smoothly, like ripples expanding across a pond. Then comes the quantum refinement. Light is not just a smooth ripple, it is quantized. Energy comes in discrete packets called photons. Each photon carries a specific amount of energy proportional to its frequency. In this picture, light regains a kind of object-like identity. A photon leaves the source, crosses space, and is absorbed somewhere else. The math works. Experiments confirm it. Solar panels respond to individual photons. Atoms emit and absorb them in precise amounts. So we end up holding both descriptions at once. Light is a wave when it propagates and a particle when it interacts. It is both continuous and discrete. This dual description becomes familiar, even comfortable. We stop questioning it. We learn to calculate interference patterns and photoelectric effects without asking what is really happening between emission and detection. But notice what remains quietly assumed in both models. Whether we imagine a wave crest moving forward or a photon darting across space, we still picture something progressing along a path. Even a spreading wave implies local motion, each oscillation advancing step by step through the vacuum. The language of propagation reinforces that idea. The wave travels. The photon moves, the signal advances. The deeper assumption is this: space is a passive container. Light moves through it, the way sound moves through air, or a boat moves across water. The vacuum is treated as emptiness, a backdrop against which motion unfolds. Even relativity, which tells us the speed of light is constant for all observers, preserves the idea of forward motion. Light still has a direction. It still connects two events by crossing the distance between them. And this model is astonishingly successful. It predicts diffraction patterns, explains refraction, governs fiber optics, and enables modern telecommunications. You can design lasers, telescopes, and cameras using these principles. From a practical standpoint, the story is complete enough to build civilization. Yet there is a subtle tension hiding inside this success. The equations describe how the electromagnetic field evolves over space and time, but they do not assign a tiny trajectory to a photon. Quantum theory calculates probabilities, not paths. General relativity tells us that light follows geodesics in curved spacetime, which means the straight line itself depends on geometry. Even the wave description implies that what moves is not a little object, but a changing field extending across space. So the textbook model, though correct in its predictions, quietly blurs a crucial distinction. It tells us how light behaves, but it encourages us to imagine something simpler than the mathematics actually describes. We carry forward the image of a beam slicing through emptiness, even when the theory speaks of fields and probabilities. And that gap between image and equation is where the real story begins to unfold. The difficulty begins when we try to ask a seemingly innocent question: where is the photon while it is traveling? Not where does it start, not where does it end, but where is it in between? In classical mechanics, this question is trivial. A thrown stone has a position and a velocity at every instant. Even if you do not measure it, you can imagine its trajectory as a smooth curve through space. That is what travel means in ordinary experience. Quantum theory refuses to grant light that privilege. In experiments like the double-slit setup, single photons are emitted one at a time toward a barrier with two narrow openings. If light were a tiny projectile, each photon would pass through either the left slit or the right slit. You would expect a simple accumulation pattern behind the barrier, two clusters corresponding to two paths. Instead, what appears is an interference pattern, alternating bright and dark fringes that can only arise if something behaves like a wave spreading through both slits simultaneously. Here is the unsettling part. The interference pattern builds up even when photons are fired individually, separated in time so that they cannot interact with one another. Each photon seems to contribute to a collective pattern, as if it had explored multiple routes before arriving. When detectors are placed to determine which slit the photon passes through, the interference disappears. The act of forcing a path destroys the pattern that required many paths. So what path did the photon take? Quantum mechanics does not assign it a single trajectory. Instead, it assigns a wave function, a mathematical object encoding probabilities. The photon is not described as being at a definite location between emission and detection. It is described by a distribution of possible outcomes. When the photon is finally absorbed, the distribution collapses to a specific event. But in transit, there is no sharply defined path in the classical sense. Even more striking is the formulation developed by Richard Feynman, who described light as taking every possible path between 2 points. Not one preferred route, not even a small collection, but all conceivable trajectories. Each path contributes a tiny amplitude, and the interference between these amplitudes determines the final probability of detection. The straight-line path emerges not because it is the only route taken, but because nearby paths reinforce one another, while distant, wildly curved paths cancel out. In that framework, asking for the single track of a photon is like asking which ripple in a pond is the real one. The question assumes a level of individuality that the mathematics does not provide. Relativity deepens the tension. According to general relativity, massive objects curve space-time itself. Light does not bend because it is pushed sideways by a force. It follows the straightest possible path in a curved geometry. Near a massive star, space-time is warped, and the straight line connecting 2 points becomes curved. When astronomers observe starlight bending around the sun during an eclipse, they are witnessing geometry in action. But if space-time is dynamic, then the path of light is not drawn on a rigid background. It is shaped by the structure of space-time itself. The photon does not travel through space as a bead on a wire. It traces out a geodesic defined by the curvature of the universe. In extreme environments, like near a black hole, these geodesics can loop and spiral in ways that defy simple intuition. The beam is no longer straight in any meaningful global sense. Even the notion of speed becomes subtle. In vacuum, light always moves at the same speed relative to any observer, but that constancy means time and space adjust themselves to preserve it. Distances contract, clocks dilate, and simultaneity becomes relative. The statement light traveled from there to here depends on how you slice space-time into moments. What appears as motion in one frame is part of a deeper space-time structure in another, so we are left with a puzzle. The classical image demands a localized object with a continuous trajectory. Quantum mechanics denies a definite path. Relativity denies a fixed background. The equations remain consistent, predictive, and astonishingly accurate. Yet the mental picture of a tiny bullet crossing empty space begins to unravel. Consider a simple thought experiment. Imagine placing detectors along what you believe to be the photon's route, attempting to map its position step by step. Each measurement disturbs the system. Each attempt to pin down location alters the wave function. You cannot track the photon the way you track a thrown baseball without changing what it is doing. The very act of confirming a path reshapes the outcome. This is not a technical inconvenience. It is a structural feature of reality. Light, at its most fundamental level, resists the category of thing moving along a line. It behaves as a quantized excitation of a field, described by probability amplitudes evolving through space-time. The clean, narrow beam in your mind is a macroscopic approximation emerging from countless underlying interactions that smooth out the quantum ambiguity. And that realization forces a deeper question. If there is no tiny object carving a precise line through the vacuum, then what exactly is moving? What does it mean for light to propagate at all? The answer requires abandoning the idea of light as a traveler and replacing it with something more abstract, yet more faithful to the equations. A perspective in which the fundamental entity is not a particle tracing a path, but a field evolving according to local laws. To reach that point, we must shift from objects to structures, from paths to patterns. Only then does the behavior of light begin to look less paradoxical and more inevitable. To move beyond the collapsing image of a tiny projectile, we have to change the category of what light is. Not refine it, not tweak it, change it. The deeper description does not begin with a particle at all. It begins with a field. In modern physics, the electromagnetic field is not a secondary feature of space. It is a fundamental entity filling all of space. At every point, there are values describing electric and magnetic components. When light is present, what exists is not a little object moving through this field, but a structured oscillation of the field itself. This distinction matters. A ripple on the surface of water does not travel as a separate thing sliding across the pond. The water molecules mostly stay where they are, oscillating locally. While the disturbance propagates, the pattern moves, not the substance. Light behaves in a similar way, except there is no pond beneath it. The field is the medium, and the oscillation is the event. When Maxwell wrote down his equations, he discovered that changes in electric fields generate magnetic fields, and changes in magnetic fields generate electric fields. These two components sustain each other, forming a self-propagating structure. The mathematics predicts waves that move at a specific speed, determined by the properties of the vacuum itself. That speed matches the measured speed of light. The conclusion was unavoidable. Light is an electromagnetic wave. Notice what that means. Nothing needs to be carried from point A to point B. There is no bead sliding along a thread. Instead, the field at one location influences the field at nearby locations. The change propagates locally, point by point, in accordance with the equations. The motion of light is the unfolding of a pattern across space. Quantum theory refines this further. What we call a photon is not a miniature marble flying forward. It is a quantized excitation of the electromagnetic field. The field itself is primary. The photon is a discrete packet of energy within that field. When a photon is emitted, what occurs is a reconfiguration of the field's state. When it is absorbed, the field interacts with matter in a localized way. In between, the evolution is governed by probability, amplitude spread across space. In this framework, asking for the photon's path becomes misplaced. The field does not possess a narrow trajectory. It evolves everywhere it has Tungo amplitude. The apparent straight line of a laser beam emerges because the field structure is highly concentrated in a particular direction, reinforced by boundary conditions and coherence. The beam looks like a line because the field's intensity is peaked along that region, not because a tiny object is carving a trench through emptiness. This perspective also clarifies gravitational bending. Light does not curve because a force pushes it sideways. The electromagnetic field evolves within spacetime, and spacetime itself is curved by mass and energy. The pattern follows the geometry available to it. The path is not imposed externally. It is encoded in the structure of spacetime. Even in empty space, what we call a vacuum, is not a void in the philosophical sense. It has properties, permittivity and permeability, that determine how electromagnetic disturbances propagate. The vacuum defines the speed at which the field oscillation advances. In that sense, space is not a passive stage. It is an active participant in the behavior of light. So the phrase light travels survives, but its meaning shifts. What travels is not a thing but a pattern of field values updating locally across space-time. The straight line is not a rigid track. It is the emergent result of constructive reinforcement among many possible contributions. The photon is not a bullet. It is an excitation. And once that shift settles in, the earlier paradoxes begin to dissolve. There was never a little path to lose. There was always a field evolving according to deeper rules. The image simplifies for calculation, but the structure beneath it is richer and far less mechanical than intuition suggests. If light does not move like a tiny object crossing empty space, then the consequences reach further than optics. Light is not just something we see. It is the fundamental messenger of the universe. Every image, every astronomical observation, every signal from distant galaxies arrives through electromagnetic interaction. If our picture of how light propagates is incomplete, then our picture of distance, timing, and causality must be reconsidered as well. When we say a star is a million light years away, we imagine light leaving it long ago and flying straight toward us across a silent void. But in the deeper description, what connects the star in your eye is a structured evolution of the electromagnetic field across curved space-time. The journey is not a marble rolling through darkness. It is a continuous unfolding of field relationships, linking events across the universe. Even simultaneity becomes fragile. In relativity, different observers slice space-time differently. What is now for one may not be now for another. Light does not simply carry information between fixed moments. It defines the structure that makes those moments comparable at all. The speed of light sets the limit for causal influence, shaping the geometry of reality itself. So when we let go of the simple beam picture, we are not losing clarity. We are trading a mechanical metaphor for a structural one. Light is not a traveler crossing space. It is an excitation woven into the fabric of fields and spacetime, evolving according to local laws that are precise, predictive, and profoundly non-intuitive. The beam was never a bullet. It was always a pattern. And once you see that, the darkness between the stars no longer looks empty. It looks active, structured, quietly carrying the architecture of reality from one event to the next.